Today we're going to just look at a linear review that you have learned from past years. We're just going to look at linear functions and their graph, and we're going to identify and use forms of line equations: slope-intercept form, point-slope form, and standard form notation. The rate of the vertical change in the horizontal change between 2 points in a line is called the slope of the line. Slope is the measure of the vertical change divided by the horizontal change. Sometimes this is referred to as rise over run, and we always use the letter M to represent slope. There's a formula that we're going to use for slope. We're going to have 2 points, x1, y1, and those could be any two numbers, and another point, x2, y2. And we're going to use the formula y2 minus y1 divided by x2 minus x1. Now, we've got a couple of special cases. When m is 0, this is a horizontal line. It's going to look it will be like something like this, a straight flat line. This is going to be when the y is equals 1. So anytime you have y equals any number, that is going to be a slope of 0. So you would have like y equals 0x plus whatever number you're at. So if you just have a number, it's a horizontal line, the slope is 0. The next one is when the slope is undefined. This is going to be a vertical line, and it will look something like x equals a number. So if I have this line right here, this would be the equation x equals 3. It's undefined, so we can't use a y to write the equation. It has to be an x. So the slope is undefined versus the horizontal slope is a slope of 0. Now we have several forms. We have standard form, ax plus by equals c, y equals mx plus b. We have point slope form, which is y minus y1 equals m times x minus x1. This comes from the slope of a line, m equals y2 minus y1 divided by x2 minus x1. And if I multiply both sides by x2 minus x1, what happens is these x2 minus x1 cancel, and we'll have y2 minus y1 equals m times x minus x1 here, where x1, y1 is a point on the line and m is the slope of the line. Looking at these next three examples, they are all in slope-intercept form. So if we have y equals mx plus b in this form, b is going to be our y-intercept, and m is going to be the slope of the line. Now, if you look before the x, there's not a number. If there's not a number, it's a 1, and we can make this into a fraction up 1 over 1. So the slope is the rise divided by the run. It always needs to be written as a fraction, where this 3 is going to be the y-intercept. That is the number where it crosses the y-axis. So here's the y-axis. I'm going to go up 1, 2, 3, and that's where I begin. So you can kind of think of that b as beginning. That's where we're going to start. And then from there, we're going to have an up 1 over 1 point. And that's going to give us our line. We can just connect those with a straight curve. So we went up 1 over 1, up 1 over 1, up 1 over 1. And then we're just going to connect all of the dots there to make a straight line. So this would be the line y equals x plus 3. Our next one, we're missing our b. So y equals negative 3x plus, this is our mx plus b. Now there's no number after it, so it's like it's a plus 0. So we don't usually write plus 0 if it's a 0, but that's going to say that we're beginning at 0. We write our slope as a fraction, which negative 3 is the rise, so that means we're going to go down 3 and over 1. down 3. And we just keep repeating that. If I have negative 3 over 1, that's the same as saying 3 over negative 1, which is also the same as negative 3 over 1. So you can write all three of these mean exactly the same thing. The negative can go on top, bottom, or out front, but you only put it in one spot. So I could go down 3 in the positive direction one, or I could go up 3 in the negative direction one. And if you notice, that's still on this straight line here. So this would be the line y equals negative 3x. Our last one, we have mx plus b. B is where we begin. It's at negative 1. I start at negative 1. My slope is 2 over 3. The rise is 2, so I go up 2, and I go over 3. So up 2 over 1, 2, 3, and I have my second point, up 2 over 1, 2, 3. And all of those are on the same point. Now, if you think of 2 over 3, that is actually the same thing as a negative 2 divided by a negative 3. A negative divided by negative is a positive. So I could also go down to left 3, and I will still be on that same line. And so that's the equation y equals 2x minus 1. My next one, I have y equals mx plus b. My beginning spot is at 1. I have negative 3 over 4. I can put it up top, or I can put it in the denominator. I can go down 3 over 4. And so this is the equation y equals negative 3x plus 1. Now, if you just have y equals a number, this is like saying y equals 0x plus 3. We're going to begin at 3. And then we're going up 0 and over whatever number you want. So y is always going to be equal 0. So if you have y equals a number, remember it's just a horizontal line at whatever number you're at. Now, x equals 5 is not in the form y equals mx plus b. This is saying the x value is 5, but x is always going to equal 5. So this is going to be a vertical line, straight up and down, and my slope is going to be undefined. So x equals 5, it's a vertical line at 5, and it has an undefined slope. Now we're going to look at 7 and 8. We're going to write the equation for the slope in slope-intercept form. My b is at 2. That's where it crosses the y-axis. And then we just need to figure out what our slope is. So I'm going to find any other point where it crosses in like a perfect spot. So I could pick any of these points here. Now I'm noticing it's going down 1, 2, down 3 over 1. So down 3 would be a negative 3 over 1. Now this just simplifies to be y equals negative 3 over 1 is just a negative 3x plus 2. And that would be the equation on number 7. Number 8, it's going to be crossing at negative 4. So if I have my y equals mx plus b, my y-intercept, my beginning point is a negative 4. Now I'm going to find another point where it's crossing in a perfect coordinate. So this would be 2, negative 3. It's not going to be in a half or anything. And then I'm going to count my slope. My rise is 2. My rise is 1 and my run is 2. So it's going to be up 1 over 2. So it's going to be 1 half x. That doesn't reduce at all. So this would be the equation. Y equals 1 half x minus 4 is the equation for number 8. Now we're going to talk about slope. Slope is the rise divided by the run. And we talked about the equation. It's going to be y2 minus y1 over x2 minus x1. Now the x is always the first coordinate, and you could put 1, could be the first one or the second one. It really doesn't matter as long as whatever you put for x, it's going to be that same number for y. So we have x1, y1, x2, y2. So we're going to put a number for each of those. So this is going to be 0.1 and 0.2. But if these were in a different order, like if you moved them around, it would work out just fine. So I'm going to take my y2 is negative 15 minus my y1 is a negative 8. Now notice I'm minusing a negative, okay? So you're going to keep the negative. If you're minusing that negative, it's going to end up being a plus in the long run. Then I'm going to take my x2, which is 17, minus my x1, which is 13. So negative 15 minus 8 is going to be the same as negative 15 plus 8. 7 minus 13 is going to be a 4. So I'm going to have a negative 7 over 4, and that would be my slope on number 9. Now number 10, we're going to use the same equation, the y2 minus y1 divided by x2 minus x1. We write x1, y1, x2, y2. We take our y2, which is negative 2, minus our y1, which is a negative 2. Keep in mind you have to write both negatives. And then x2 is negative 3 minus 5. Now, in our numerator, a negative and a negative make a positive, so I have a negative 2 plus 2 is going to be a 0 over negative 8, which is a slope of 0. If it's a slope of 0, it should be a horizontal line. So if I were graphing this, I would have 5, negative 2. I would also have negative 3, negative 2. And notice I'm going to have a horizontal line here. This would be the equation y equals a negative 2. Y is always going to equal negative 2. Number 11, we have x1, y1, x2, y2. y2 is 20 minus a negative 12. My x2 is going to be 5 minus a negative 3. So two negatives make a positive. 20 plus 12 is 32. 5 plus 3 is 8. 8 times 4 is 32. So the number 11 has a slope of 4. Now on number 12, both of the x values are going to be 7. So I know that this is going to have 7, negative 1 is a point, and 7, 3 is a point. And so this is going to be a vertical line. It should have an undefined slope. Now what does that look like when I use my formula? It's still going to work out. I have my x1, y1, x2, y2. 3 minus a negative 1. And in the denominator, I have 7 minus 7. Now 7 minus 7 is a 0. 3 minus a negative 1 is 3 plus 1, which is 4. Any fraction where you have a 0 in the denominator cannot exist. That is undefined. And if you are wondering how to remember that, a 0 in the numerator is okay. And a 0, no, you cannot have a 0 in the denominator. Not okay. So this one is fine. Any 0 in the numerator is just 0, but a 0 in the denominator is undefined. There is no number times 0 that will ever equal 4. Now, given a point on a line and the slope of a line, we're going to write an equation of the slope of the line in slope-intercept form. So slope-intercept form is y equals mx plus b. We know that our slope is negative 3/2. Now we need to figure out what this b is. Right now we don't know what that is. So for every xy the b will be the same. So I'm going to take this 2, negative 2, and I'm going to substitute it in for my x and my y. In for y, I'm going to put a negative 2. And in for x, I'm going to also put a 2. And then I'm going to solve for b. Now here my 2's cancel. Negative 2 equals negative 3 plus b. So I'm going to add 3 to both sides. And so my b is going to equal a 1. So I'm going to take that 1 and put it into my equation here. So my answer will be y equals negative 3 halves x plus 1. Number 14 is going to be the same. I have my x and my y. Y equals mx plus b. I know my m is 5/4. So I know y equals 5/4 x plus something. I'm going to figure out what that is by taking my x and y and substituting it in for my equation. So 3 equals 5/4. My x is a 4 plus b. I'm just going to leave it as a b. My 4's cancel. So 3 equals 5 plus b. Minus 5 from both sides. B equals a negative 2. So my equation is going to be y equals 5/4 x mx plus b. My b is minus 2. So this would be the equation of a point going through of a line going through the point 4, 3 and having a slope of 5/4. Now the hardest ones are when you have 2 points. So we have to combine the last 2 things we've done. First thing we're going to do is find our slope. We're going to use our y2 minus y1 divided by x2 minus x1. x1, y1, x2, y2. Which gives us 4 minus 1 over 1 minus 5. This gives us a 3 over negative 4. So that would be our slope. We're going to take our y equals m, which is negative 3/4 x plus b. Now, I can use either point. I can use this point or this point. Either one will work. So let's go ahead and you want to kind of look, is the one going to be easier than the other? Maybe this one, because then I don't have to times it by 5. Let's put 1, 4, but really either one should be just fine. So I'm in for my y, I'm going to put a 4 equals negative 3/4 times x, which is 1, plus b. So 4 equals negative 3/4 plus b. I'm going to add 3/4 to both sides. So b is going to be 4 3/4. That would be the mixed number, but we don't want to write things as mixed numbers here. What you can do is you can times 4 times 4 is 16 plus 3 is 19/4. Or you could just get a common denominator and add 16/4 plus 3/4. But either way, your b is going to be 19/4. So my equation is going to be y equals negative 3/4 x, and then my b right here, we're plugging everything in here. We want my m and my b. My b is 19/4. Okay, let's do another one. We're going to go ahead and use our y2 minus y1. So x1, y1, x2, y2. We're going to kind of follow along what we did on the last one. First thing we're going to do is find our slope. 3 minus 3 is 0. 2 minus a negative 5 is 2 plus 5, which is 7. 0 divided by 7 is 0. This has a slope of 0. This is going to be a horizontal line. The x changes, but notice the y is always 3. So my equation is just going to be y equals 3 here. So we've got the point -5, 3. And we've got the point 2, 3. It's a horizontal line. Y is always equal to 3 there. If I plugged in y equals mx plus b, my slope is 0. So 0 times anything is 0. So these are just going to cancel out. And my y is going to equal b. So I can just take whatever my y is in either equation, and it's always 3. So 3 is going to be equal my b, and so y equals 3. So you can do it with the formula, or you can just kind of reason it out. Now, if you have, like on number 17, we have a line. We're going to write the linear equation for the graph in slope-intercept form. First thing you want to do is you want to find 2 points where the line intersects at a whole point. So you can use either one of these. You can take the point. We've got 1, 3 here, and -2, 1, and you can do your y2 minus y1 divided by x2 minus x1. 3 minus 1 is 2. 1 minus a -2 is 1 plus 2, which is 3. We should get 2/3. You can also count it. So if I take my point, I go up 2 over 1, 2, 3. This would also be a 2/3 slope. Now notice when I look at this, this is not crossing my y-intercept at a nice place. So this is going to give us a fraction here. If I have my y equals mx plus b, I know my slope is 2/3. I can take either point. Let's do 1, 3 since they're both positive. 3 equals 2/3. My x is a 1 plus b. 1 times 2/3 is 2/3. I'm going to minus 2/3 from both sides. And so 3 is the same as 9/3. 9/3 minus 2/3 is 7/3. So b is going to be 7/3. So the equation of this line is y equals 2/3 x. We're going to use this equation. We found what our b is plus 7/3. Now, if I'm looking at this, does this make sense? 3 goes into 7 2 times. So it's a little more. 3 goes into 7 2 times, minus 6 is 2 and 1/3. And if you look at this picture, up 1, 2, and just a little bit, that makes sense. That's reasonable that this would be the equation of this line.